I want to touch on some of the elements of the string builder and the string buffer, and then we're going to, after that, jump into the assignments and work through each of the assignments with you all today. The first assignment it utilizes arrays as well as string buffers and or string concatenation. So I want to make sure you guys are thinking about how to use the tools that are in front of you. Samuel? All right, hang on here real quick, class. Let me... Is that Christian? Okay. You guys seen Omar? Anyone seen Omar? Okay. And why is it doing that? That was weird. Okay, you all were getting my other class I teach. All right. I'm going to make sure it's showing what I think it's showing. Okay, so we're going to be talking about a string builder and string buffer a little bit. Just keep in mind that string buffer is thread safe. The really only difference between string buffer and string builder is that buffer is synchronized. That's the only difference. If you look at the source code, you'll see that string buffer is synchronized. And you don't want to use string buffer unless, again, you're in a multi-threaded application. When it comes to the string builder, we demonstrated this last week. You call the class, create the object name equals new string builder, and you can even pre-populate it with text in the constructor. Or you can leave it blank. Now, this is the interesting thing about the string builder and the string buffer classes. How many of you have taken other computer courses where they talk about binary, memory management, RAM, hardware, things like that? So for example, oh, there's Omar. All right, give me 1 second here. Close that. All right, so we're 100% today except for Brandon then. Okay. Okay, so how many of you guys have built a PC before? Let me just start it that way. What size did it usually come in? So you usually start with 2, 4, 8, 16, 32, 64, 128, 256, 512, 1028. I've been doing this a long time. Right? Those are the multiples because that's the way binary works. It all comes down again to the idea of the circuits of switching on and off a switch. Okay? So when it comes to buffers in your memory block for string builder and string buffer, they all come with a standard memory allocation. And the memory allocation they come with, the capacity or the base capacity is always 16. Okay? And if you if the string of characters is beyond 16 characters, what it automatically does is it reallocates again, but this time when it reallocates, it does 16 times 2 plus 2. So think about that for a moment. 16 times 2 is 32 plus 2, 34. And so then the next allocation block that you'll use is the base times 2 plus 2. So it grows incrementally. As you reach that capacity, it automatically buffers away memory for you automatically. Now it does this with string buffer and string builder, because the idea, remember, strings are they're stored in memory, they're immutable, right? So string buffer and string builder, it's trying to reserve memory for you so it'll work quicker. Are you guys good over there? Yeah? Okay. Let's not carry on too many conversations so we distract everyone. All right, so you can set the length. You can tell the string buffer and string builder to set the length automatically to a certain number of characters. And there's the, as well as you can call capacity, and capacity will give you the length. Okay? All right. Let me jump forward here a little bit. So you can set in the string builder or the string buffer, you have the following constructors. An empty constructor gives you just a simple string builder object that you can use. Or you can specify the capacity up front. The benefit of specifying the capacity is the JVM doesn't have to go through the extra effort of doubling the memory for you, because it doesn't know how many characters you're going to be passing into it. If you know, then you can pass it in and it takes out some of that extra processing. All right. Standard methods: append, insert, set character at, character at. So append does what you would think it does. It appends a sequence of characters to the end of your string. So if you have high class, and high class is the string literal inside of your string buffer or your string builder, and you take that object sb.append and you say, I'm going to append space good morning. It's going to append, it'll be high class space good morning. It just appends it. You can also insert characters at a specific location. So what it literally does is it takes that character array and it pushes it out so many characters for you. You can set one character at that location, or you can get a particular character at a location. Okay. In this example here, it's hard to see on my screen. It's very tiny. In this example here, we have the string builder class initializing an object called string. And we see that we're passing in an empty string. We're creating a second one. And this time we're saying 2. We're saying the times 4. Times is, 200,000. And we have a factor as well as 1 million, right? So we're saying 4 times 200,000. And that gives us, So we set the local date and time. We get the start time, which is in nanoseconds. Okay. And start time is a long, and end time is a long. Then we're doing this this range of operations, string, append, Java. And how many times are we going to do that? Think about that for a moment. We're getting ready to append something, Java, 800,000 times, right? Now, when you're using, this is where you want to use string builder. You would not want to say string equals new string plus Java. 800,000 times, you would definitely see a blip in your memory. But with string builder, the power behind this is that it actually lessens the amount of memory that you're going to use. This is where you really want to use string builder. If you're using just on one line, you're saying string equals string plus a new set of characters and only doing it one time, just do that. There's no sense in you initializing a string builder object. But if you're using large amounts of loops, like 800,000 times, use a string builder. It's more efficient. All right. So then we go on with the code. We get the local time, which is now. And now is what? Now is a local date time. Then we say now get nano, and we apply that to the end time. So we're capturing the start and the stop times of this processing. That's what they're doing here. And then they're spitting it out for you, giving you an estimate of how long it took to run this particular operation. Then they're doing the same thing over here again, this time with times, right? It's the same as above, right? Yeah, it is. All right. And then doing the same processes again. Okay. So a few do's and don'ts. Don't attempt to compare strings with standard comparison operators. What are the standard comparison operators? We use them for primitives and things. The two equal signs, right? We don't compare strings with equal signs. But what you do compare strings with are the equals method or the equals ignore case. Don't forget that starts with and ends with and replace. These are case sensitive methods. And it doesn't say it here, but you may think, hey, I could just say string builder dot equals my other string builder. Don't do that, because that comparison doesn't reference the values, it references the memory location. So it's just the opposite of your string class. So if you went to say you create a string builder like the one we had up there a minute ago, and you went to compare those two strings, they would not be equal, because you have to spit out the string. You have to say string builder dot toString dot equals ignore case SB toString in order to do that. And I'll give you a demonstration in a moment on some of that. Don't use a string builder or a string buffer if you're just doing very, very basic string manipulations. However, if you're in a loop of 20 or more, 10 or more, use a string builder. It makes more sense. Also, string builders, they're easier to read than string plus string. Okay, it's more English-like syntax. All right, any questions so far? No? It's a good time to think about it. All right, so we talked about our string variables. We talked about the character class. We've talked about how strings are immutable, the importance of the equals method, as well as equal ignore case. And we've looked at the toString method. We've talked about, so far this week, the integer, the parseInt, double parse double, and the string builder classes. Okay. I want you guys to follow along with me here. We're going to be working through the assignments, so it's to your benefit to really follow along. Okay. I appreciate it. Thank you, Omar. That door is a little interesting. Okay, we are going to create a new class. And if we look at our homework assignment for this week, our code requirement is to create a baby name combination class, combinator. Combination. Yeah. So we'll call it baby name combination. How many of you know of names where they take the parent's name and they combine them together to create? Yeah. What's that? Yes, it is. My wife's name is Geraldine, and my name is Michael. And so we were playing around because I think it's a Filipino tradition. Yeah. So we were gonna, my first son's name is Michael, and so we were joking with my son and saying, we could have called you Jerkle, or Midgerel, or just Midgery, right? Because he would have been in misery. Could you imagine him in the first day of kindergarten? Jerkle, Jerkle. Yeah. My daughter's name is Haani, and stateside, everyone had a hard time pronouncing her name. Here, it's pretty common. So my dad, he told me and my wife, he says, you need to come up with a nickname for her because I'm just going to call her Honey. Anyways, all right. So we're going to have a baby name combination generator. And we're going to accept, according to our code requirements, it's going to take 3 names, right? And we're going to combine the 3 names in every possible pattern. That sounds like fun. How many times is that? It's just 9. All right. So the first thing we're going to do, we're going to accept names in. How are we going to do that? Tell me what to type. Scanner. Okay. And we'll call it scanner. Equals new. And what do we put inside the scanner? System.in. And to make life easier, we're going to say scanner, and we need to apply a delimiter, right? So we're going to say use delimiter. And what delimiter am I saying that you guys should use more of? //n. Yeah. Okay. So we have our scanner. When we run the program needs to alert somebody to do something, right? So how are we going to do this? What do we want to tell them? Please input should we say a name? 3 names? What do you guys want to say? A name. Or how about 1? Yeah, a name. Okay. And then we're going to type, what do we type next? Scanner. Next. Okay. And we need to assign our scanner to something, right? Okay. Well, let's pause there for a second. We're going to take 3 names, and we're going to need to do a combination of every name. So how are we going to do that? I think it's beneficial at this point to declare an array. Here's the first part of it. I'm going to call it names. You all tell me what else to type. Should I say equals? Yeah. New what? Okay, and how many array elements? 3. Remember, for arrays, you always have to declare the capacity of the array. Because remember, it's taking up location in memory. So you're saying use this many locations in memory, right? Okay, so we have a string. So let's back up here. So we have names. How do I specify the very first entry point of the array for this? 0. Very good. Okay, now we need to request another entry, right? Request the user to enter another name. So I'm going to copy and paste. Please input your, okay, another name. And I'm going to say names. What array index do I use now? 1 equals scanner dot next. Okay. So far we're scanning for input. We're storing the values in an array, right? So we need to do it one more time, right? Please input a final name. All right, so what down here for the array, what do I put? What is that? 2? Okay. All right, so we have the array. We've captured all of the data and stored it in an array of the names, right? And now we need to somehow iterate through this array and combine names. Yeah. Interesting, right? So let's figure out how we're going to do this. This might be a good place to declare a what type of object? What do you guys think? If I'm going to be in a loop and I'm going to be concatenating names, what type of string object should I use? We just talked about it. What's that? I could do a string buffer, but which one is better for memory? String builder. All right. So I call it string builder, and I'm going to call it my name. Let's say baby name builder equals new. You guys are just waiting for me to type, aren't you? What should I put on the end of this? String builder. Okay. All right. I'm going to... Oh, by the way, don't do this. If you do that and try to compile, it's going to throw a null pointer exception. Okay? Don't do that. You can do that, but that doesn't really make much sense, right? You could do this, just empty string or leave it empty completely. Okay? All right, so we need to loop. What kind of loop looping construct should we use? You want to use while? Okay, we'll use for. You guys are just downright guessing right now. Yeah. While, for, do. All right, so I'm going to say int what? Very good, equals 0. And then I need to say I is less than. Less than 3? Okay. Now what's another way I could do this? Say I don't know the length of the array. How would I do this? Names what? length. There you go. Right? I can do it like that, right? If I don't know the length of the array, I could always just say, just give me the length of the array from the array, right? Okay, so then I need to do something else here. What else do I need to do? I++. All right. So now I've got my first part. Let's see here. I'm going to say string name equals names. And what am I going to put inside this bracket here? Awesome. You guys are with it. All right. We got the first name, but now we need to compare it against all other names. So what do we do? What do we do? Problems. Think about it. We could say another for loop. Int j, Hij, yeah, that makes sense, is 0. And j is less than names dot length, okay? And j, whoops, j plus plus. Now, I want to combine names, but they can't be combinations of the same name, right? Yes, they can't be combinations of the same name. So I'm going to say if name equals ignore case names j, but I need to make this a not statement. How do I make it a not statement? Where do I put the exclamation? Front of names. All right, so now it's not. If names is not equals ignore case to the name in j, then I'm going to say baby name builder append name. What else should I do? Dot append. You guys like spaces between your names? You want them all together? Okay, so spaces. Whoops. So I could do that. And then I could say append names j. All right. What did you notice here about this builder? There should be something pretty obvious about it. Append takes a character, it takes a parameter, right? But it also returns something. Does append return void? What does it return? It returns itself. Hence, I can call dot append again. You see that? So if I look at it right here, you see that? Does that make it a little easier to understand? How about I do this? I'll go into the Java doc. You can control click and IntelliJ and go into the class. And you can see that append, it takes in a string, it appends it to this object, right? And then it returns itself. So the benefit there is that you can keep calling dot append, dot append, dot append, dot append, bada bing, right? You can keep calling that. Okay, so now let's look at our looping, what we got going on. So we've declared baby name builder. We've said we've got a for loop that's going to iterate through the names. On the first iteration, it's going to assign names to name. And then it's going to do a comparison and say, if name does not equal the name over here in J, append name. And then it's going to go through that inner loop 3 times, and then it's going to go back out to the outer loop, and it's going to keep checking these conditions and keep appending and keep going. Now be honest with me. How many, if you're having difficulty following the logic, let's break it down, because we're almost done with the assignment here. So, all right, Chris, anybody else? Some of you are saying, I don't want to, you just got to be honest. It's okay. Let's look at it. Okay, so first loop, let's walk through the loop. What's happening? Okay, so we get the names. Our first loop, I is 0, right? And so we're going to say, give me the index of I. We don't know what I is because we haven't entered the names yet. But let's say it's Michael. So now the string name will be Michael at this point. And let's say the second name is Geraldine. And let's say the third name is Thomas. All right? So Michael, Geraldine, and Thomas. So I goes to name. That'll be Michael. I come down here to the next inner loop. J is still 0, and J being 0 here is going to give me Michael. So if name does not equal Michael, then go on to this. So what's going to happen on the second looping mechanism down here? First iteration, it's going to skip, right? Because it doesn't meet the criteria. Second iteration, J now is 1. 1 will be Geraldine. If Michael does not equal Geraldine, it's going to append my name, space, Geraldine. Right? Okay? And then it's going to exit out of this for loop, come up here. It's going to take I, which is now Geraldine. It's going to come down here to the second loop. J is 0 again, because we've declared it to be so inside the inner loop. And so J is going to get 0, which will be Michael, and it'll say Geraldine space Michael. Make sense? So we're incrementally working through every possible name combination, right? Okay. And we need to probably do this down here just so that it makes more sense for readability. You understand what I did there? I'm putting a name space because after each iteration we want different combinations, right? So I will put a comma so we separate our combinations. Now I could take this a step further because we expect there to be 9 iterations of this. So we could say dot append count dot append, maybe something like that. And then down here, inside my if statement, I want to say count plus plus. Okay? All right. In IntelliJ, you can click on the curly brackets and you can see which code block it's highlighting. And it indents for you, which makes it easier to read and group it together. So this one's referring to the if statement. This one's referring to the for. This one's referring to that. So something I used to do early on when I was trying to visualize my code and get better understanding of it, I would say something like this: end if, end for, end enter for. Yeah. end outer for. It helps to kind of see where things are at, so that I know that down here then, this one here is the end of the public static void main method. So here I want to output the final name. System out print line. Your baby name combinations are system out print line baby name builder dot toString. All right, let's run it and see what we have happen, because I have a suspicion it's going to append one big long string name, right? That may not be very pretty for us to read visually, but let's just run it and see what we have. Let's run it too and see if we have any mistakes. Okay, I'm going to run the code. Okay, so let's enter a name. Do you have a name you'd like me to enter? Michael. You're cheating. Oops, I can't spell my own name. All right, enter another name. Let's enter another name. Oh my goodness. All right, enter another name. Jackson. Okay. Michael Geraldine Jackson. That's interesting. All right, there's our name combinations. Michael Geraldine, Michael Jackson, Geraldine Michael, Geraldine Jackson, Jackson Michael, Jackson Geraldine. Oh, so there's only 6, right? Does that make sense? Should be 9, shouldn't there? What have we missed? Yours has an error? So what do we miss in our logic? Let's think about this. So we're going to you know what we're missing?
If it's going to be 9, then the remaining 3 will be like Michael, Geraldine, and Jackson.
Yeah, you're right. Very true. There we go. All right, so readability, though, there's a problem here, right? That doesn't really make a lot of sense, readable. We'd want this to be kind of laid out in maybe a tabular format, maybe? What do you think? So what can we do here at the end to make it more tabular? Yeah, remember what that does? It throws a new line character. All right, so let's try it again. And we got to come up with different names. All right. All right, different names, guys. John. Cena. And someone said Doe. Is this D-O-H? Doe or Doe? D-O-E? Oh. I did something wrong here. What did I do wrong? I think it... New line character didn't give me what I was expecting. Let's see here. What's another way we could do that? I got an idea for you. How about we throw this into another array? Are you able to make a project?
I started the class.
Okay. Okay, so let's create a new string, and we're going to call this baby name combos equals new string, and we're saying there are 6 combinations right now. So at the end of every combination, we're going to say we can just do this, right? ToString, and we can say baby name combos is I need to create a different iterator because count will cause a problem. Okay. All right, y'all understand what we've done so far? Baby name combos, IT, we're assigning it into a new array, right? And then we're going to come down here, and we have to iterate through our array, don't we? So for int equals, let's see, HIJK equals 0, K is less than baby name combos dot length K plus plus. Wait till we get to array lists and list, because I really don't like working in arrays, but array lists are a lot easier to, collections are a lot easier to work with. All right, so now we're going to say system out print line, baby name combos, K. I have no idea if this is going to work, doing it on the fly with you all. It's kind of fun that way. All right, need a name. How about great couples? Okay, Romeo, Juliet, and what's their last name? There we go. Oh no. Yeah. So our logic is malaligned, but we are producing. Not really. Yeah, we messed up. So let's say baby name combinator. Let's just go back to this. ToString. We don't need that. I'm going to take out the IT. We got the count. Jessa, could you grab that door for me? Let's see. Thinking we could just do that. It's not letting me. Okay. We'll have to just bear with the craziness for right now. All right, so the system out print line, baby name builder, ToString. Okay. We'll run this again with the Romeo, Juliet, dead. Romeo, Juliet, dead. There you go. Romeo, Juliet. Romeo dead. Juliet, Romeo. Juliet's dead. Dead Romeo, dead Juliet. All right. So that's the first one. There's a lot that's going on there in that code. Does it make sense to everyone so far how we've done this for the combinations? All right, let's go on to the second assignment here. The second assignment, 3-letter acronyms are common in the business world. That's true. For example, in Java, you use IDE, Integrated Development Environment, and JDK, Java Development Kit, to write programs used by a JVM, Java Virtual Machine, that you might send over a LAN, Local Area Network. Programmers even use the acronym TLA to stand for 3-letter acronym, and sometimes when I'm texting my wife, I say BRB, LOL. Sometimes it's even more than that, right? Raffle. All right, so here's our code requirement. We need to write a program that allows users to enter 3 words and display appropriate 3-letter acronym in all uppercase letters. If the user enters more than 3 words, ignore the extra words. Save the file as acronym generator. Okay, so let's copy this, acronym generator. I'm going to come back over here in my source. Source equals new class. Paste it in there. Public, let's say PSVM. All right. There are numerous ways to do this one as well, so let's think about it. We're going to have one input that accepts 3 words. So we're going to start off with a scanner, right? Equals new scanner system.in. We don't have to for this one because we're only going to accept one input, but I'm just going to say use delimiter again. I'm going to alert the user. What do we want to alert the user? What do we want to say? What should I say here? Huh? Okay, please enter 3 words. Do we want it separated by anything? Nope, it has to be all in one line. That's the code requirement. So what are we going to tell the user to enter it as, though? Do we want to tell the user to enter it in spaces, in commas, in dashes, in... How do we want to separate the words? Huh? Dashes? Okay, please enter 3 words with dashes in between. All right, just as the scanner class has a use delimiter, the use delimiter for the scanner class, because it's scanning system input, right? System.in. And it's delimiting input based on the new line character. We can also use a delimiter in our string and then break that string up, right? All right, so we're going to take scanner next. We're going to assign this to possible 3 words. And then we want to do something with this. We want to validate, right, that they've used dashes. So let's say split, and we're going to split on what? On the dash. Now, what split gives us, notice the return value that split gives. What does that return? What type of string though? It's got brackets on it though, right? So what type of string is it returning? A string array, absolutely. So if you actually let IntelliJ generate it, you're going to see that it returns a string array. Well, how nice is that? We can say split on whether it be spaces, dashes, whatever, and it's going to spit it back out as an array of strings. Okay, so there's my words. So the code requirement says if they enter more than 3 words, we need to ignore it, right? So we don't care if there are more than 3 words. So, but there has to be at least 3 words. So what could we do here? If words.length is less than 3, what do we want to tell the user to do? Huh? To enter more words, right? All right. Hey, crazy. You did not enter 3 words. You wouldn't really say that to your boss. Be like, no, don't do that. But we're having fun, so this is okay. So we would say, please enter another. Please enter some more words. All right. So we're going to take our scanner again. And next, string more words. And we need to figure out if they have if they've used the delimiter that we asked them to use. But we're just going to assume that in this case, to keep our logic simple, that they've only entered 1 word. Okay? We don't want to make this too complex for us already. All right. If we're expecting 3 words, and this comes back and there's only 2 words, well, it kind of creates a bit of a problem, right? So one of the things that we can do is say string expected, let's call it something else. Word holder equals new string, and that's 3. Okay, let's loop through our possible words. So int I equals 0, I is less than the number of words dot length, I plus plus. We're going to come over here to our word holder. Say I equals words I. I. Okay. So now we've captured all the possible words. We've put it into a word array. We've looped through the word array and put it in our word holder because we only care about up to 3, right? If I equals 2, actually, how do we need to say this? If I is greater, let's see, if I is less than 3. Now think about why I'm doing that. What happens if I take something and try to put it into an array that only has 3? Say I try to take 4 entries and put it in something that can only take 3 entries. You're going to get an error, right? And the type of error you would get is an index array bounds error, right? All right, so what I'm doing is I'm saying if I is less than 3, this is okay to do. Make sense? Okay. All right, up here we're saying if the words dot length is less than 3, then we know that it doesn't have the appropriate number of words in it, right? It has maybe only 1 or 2 words in it, which would be array index of 0 and 1. So then I've stored more words, but there's a problem with my code so far, and it has to do with the declaration of the variable more words. I can only use more words inside the code block of that if statement. Do you see that? And I might want to use that somewhere else. So let's declare this right here so that more words might be accessible somewhere else. So now what I've done is I've said more words. It's assigned through the scanner only if there's not 3 inputs. Let's change that. All right. Down here, I'm looping through, I'm putting into my word holder. Okay. If word holder dot length is less than 3, word holder index array number 2 equals more words. Y'all understand the logic so far behind that? Now there's another error here because this is never initialized. I need to at least put it with an empty string block. Okay, so now I've got all my words in a word holder, but what I'm after is creating an acronym. So what would be the next thing I'd want to do? Yeah. Capitalize what though? The first letter? Okay. So we need to iterate through our word holder, right? For int j equals 0, word holder length j plus plus. Why is that complaining? Oh, because j has to be less than the word holder. I forgot to do that. Okay. So now I'm going to take word holder into the array index of it. And I'm going to say to uppercase, and then I'm going to say character at what index? Because 0 is the first of an array, right? Okay. Now think about this. I've got the word holder, just this part right here. Let me put it in parentheses so it kind of gives a little bit more separation visibly for you guys. Word holder is an array. I'm passing in an index into that array, which is going to give me the string contents of that array. And then from that string content, I'm using the to uppercase method to uppercase that word, and to uppercase returns a string, so I can also use the method char at. You guys understand? You guys are quiet. Don't be afraid. I mean, you know, it's okay to guess and to think about this. So this is going to return a char. And I have to do something with that char. So char array acronym equals new char. What do I have to supply in here? I have to give it a number, right? We're only working with three word acronyms, right? So it's going to be a 3, right? All right. And I come over here and I say acronym equals all of this mess. But I need to put something in there. What do I put in? Just a J. Because J is at 0 right now, right? Okay. I have an acronym that is all of that. So I could say string my acronym equals, I think this, I can't remember. There you go. Because a string can take an array of characters. Because the string is an array of characters. Right? So system out print line. Your acronym is okay. That was a lot of code. I don't even know if this is going to work yet, because we haven't tested it. You guys want to see it fail, or you want to see it work? All right, let's go through it and see what happens. And if we mess up, we'll go from there. All right, so enter 3 words with dashes in between. Northern Marianas College. But we got to put dashes. Hey, crazy, you did not enter 3 words. What did we do wrong?
Try N-M-C.
Something doesn't make sense. Let's do this. It's time for the debugger. Okay. This is okay. We work through problems like this all the time. You step through it incrementally and figure out what's going on. All right, so let me... Huh? Got it to work? Northern Marianas College. Something is different this time. I wonder if it was because I went back and entered it after the fact. Yeah. All right, so the words, it's actually in there, right? We can see Northern Marianas College. I think it was just the fact that I went back and did it after the fact. All right, so we'll go on down here. If word length is less than 3, this skips over it. Now we're going to pass our words into our word holder. Okay, word holder length is 3. Okay, chart our acronym. Okay, there's NMC, and your acronym is... Yes. All right, where did it go? Where's the execution console? All right, it's working, but I can't can't see it. So let me just run it now. Here we go. Marianas dash Northern dash school. MNC. MNS. Right? All right, so it works. Oh, you want to... Oh, I was hoping you wouldn't say that, but okay. No, but you're right. Let's see, Northern Marianas. Hey, crazy, you did not enter 3 words. Please enter another word. Okay. College. Oh, null pointer exception. Let's see here. Where did it fail at? Line 33? Okay, so something at line 33 it didn't like. System out. Print line. More, let's see. This is also a debugging technique if you're uncomfortable. You can just put system out print lines everywhere. All right. Let's try that again. We said I guess it doesn't matter. Northern Marianas. Hey, crazy. Let's see. College. Line 34. So if word holder is less than 3. So system out print line. Word holder length. You guys follow along what I'm doing? So we type it in again. Word holder length was 3. So why was it 3 at that point? Because we're checking the wrong value at this point. That's why. All right, tell me what I did wrong, because I already see what I did wrong. Do y'all know? This should be words. I was checking the wrong value. Do you see that? Because word holder will always be 3, because I initialized it to 3. But words will only be whatever it's generated to be. Does that make sense? All right, so let's run it again. So, Northern Marianas, enter the third one, college. There you go. Okay. Any questions so far? Let's modify it real quick because we're using dashes here, but you don't necessarily have to use a dash. You can use a space. So now if we run it, we can just literally say this. We can type in, this is too many words. Will it work? Now think about that. How many words is that exactly? 8 words. All right. So let's, before I hit enter, let's calculate, read through what we're doing. So words here is what? It's going to be a length of 8. If words is less than 3, do this. Well, it won't do that, so that's fine. However, words, the length is 8, so it's going to iterate. When it gets to greater than 3, it's going to add something that doesn't exist. You see what I'm talking about? This will actually throw an error. It will throw an array index out of bounds. It didn't throw an array index out of bounds. It just stopped, didn't it? My estimation was it would have. Okay. Let's look at it, though, and figure out why it didn't throw that error, because this is important for us to learn as well. So, word holder length is 3. When so as long as I is less than 3, it's going to add the words, right? So our check is in place right there. This right here, this ensures we don't overrun our array index. Does that make sense? Because what we're doing there, we're catching it. All right. Any other changes that you guys would like to make to this today? We've basically done your homework assignments for you this week. You guys don't look happy. All right. The only thing you have to finish up this week is your discussion questions, right? Yeah. All right. So this is, so far in the class, we have looked at arrays, we've looked at strings, string buffers, we've looked at loops, right? We've covered just about all of the basics except getting into larger polymorphic ideas, polymorphism. And I'll have to check the lesson for next week. I think we start to get into some of that next week. Yeah. All right, guys, if you don't have any questions, I'm going to close the class at this time, and I've got another 10 minutes, so I'll stay behind for the next 10 minutes, answer any questions if you're having problems. Maybe it was your project that's due today. So, all right. Have a good one.